Okay, so I mentioned that the topic would just be continuing optimization. So remember, optimization is finding the max and the min, right? Sometimes if we wanted the optimal circumstances, we would want the max, right? And then sometimes we would want the min. The difference between what we did on Monday and what we're doing today is that today we're likely going to have to come up with our own formulas. So they're not going to be cookie cutter problems. So for a class like this one, these are the problems that I actually really like and that I want y'all to be able to follow. So here are some tips just in general when you're struggling to come up with your own formula. If possible, draw a picture. Okay, that's something I always tell my students, particularly like in junior high or geometry or anything like that. Step number 2 is you want to find an expression or formula for whatever quantity you're trying to optimize. So in other words, whatever you're trying to find the max or the min of. But you want to find that as a function with one variable, and often that's going to be the challenge of these problems. So we don't know how to find derivatives of things with more than one variable yet, at least. Okay, so I'm going to put a star by this. This is the most important step. It's often the most challenging, okay, but it's really the gist of the whole thing. And then you're going to find the max or the min just using our traditional way. Okay, so how did we find the max or the min? We set the derivative equal to 0, right? So we're going to set the derivative equal to 0. And find critical points or endpoints if necessary. So for Monday, what's the only 2 general locations that maxes and mins can be at? So endpoints, right, or where else? Or critical points, right, or turning points. Okay. So I say if necessary because the endpoints may not make sense for the problems that we're doing. Okay. Often in the real life problems we're doing, for instance, our variable will need to be positive, so the understood beginning endpoint will be 0. Okay, so let's practice a few of these. That's really going to be mostly what we do today, is just tackle some problems and see if we can come up with the equations for them. So let's say that you have 3,000 yards of fencing. To enclose a rectangular piece of land. And let's say that it is bordering a river. And I want you to tell me what is the largest area you can enclose if no fencing is put at the riverside. All right, so the first thing that we need to do is draw a picture, okay, because I think it will probably help us. So we have a river. It's got a current, that's what that is. And then we want our fencing to go somewhat like this. Notice, where did I not put fencing? On the river itself, right? Okay. So this is the fence, though. Because my artistic skills are poor, we'll label that the river. Maybe we'll draw like a little duck. on the riverbed. Beautiful, right? Okay, so the point is that what do we know about the fencing? Yeah, the fencing is 3,000 yards. Okay, now do we put fencing in the whole area of the land, or do we do something else? Yeah, so we have that the perimeter equals 3,000. But it's not standard perimeter. How come? Because we're not adding one of those sides, right? So what is normally the perimeter of a rectangle? It's normally like 2 length plus 2 width, right? So one of those sides is going to be missing, so we're just going to say 2L plus W. Okay, so we're going to come back to that, okay? But what are we actually trying to maximize or minimize? We're trying to maximize area, right? And what's the formula for area of a rectangle? The formula for area of a rectangle is what? Length times width. Okay, so what's the problem with me just finding the derivative of this right now? How many variables do I have? 2. How many do I want to have? Only 1. Okay, so I'm going to take my equation over here that I know something about, okay, and I'm going to first plug in 3,000. But notice that if I solved for W, that would be relatively easy, right? I could also solve for length, but it's easier to solve for W, frankly. So notice that W is equal to 3,000 minus 2L. Okay, so what I'm going to do is I'm going to substitute that now in here. Why would I want to do that? How many variables would that leave me with if I substitute something in for W that involves L? It'll only leave me with the L, right? So now area is equal to length times 3,000 minus 2L. So area, if we do distributive property, is equal to 3,000 L minus 2L squared. I do my L's cursive there because I don't want them to look like ones. You don't have to do that. Okay. So we did the hardest part of the problem. The hardest part of the problem is getting the formula to have one variable so that we can take the what? Derivative and set that equal to 0. So A prime is going to be 3,000 minus 4L, right? And we're going to set that equal to 0. So if you solve, you would add 4L to both sides probably, right? So you're going to get L equals 750 yards. Okay, but is the problem asking me just for length? No, it's actually asking me for the area itself, right? So what else do we need to know now? W. Yeah, now we can find W, but that's pretty easy, right? Because now we know what L is, okay? So we have a formula for W. W is equal to 3,000 minus 2 times 750. Kind of squeezing it in there. So what do we end up getting for W then? It's 3,000 minus 1,500, so 1,500 yards. So I'm going to give up and go to the next page. So in the end, my maximum area, how would I find it? Hey. Yeah, so it would be 750 yards by 1,500 yards. Okay, so the maximum area would be 1,125,000 yards squared. Notice area is literally dimensions squared because you're doing 1 yard measurement times another. Okay, so again, the gist of what we're doing is find a formula with how many variables? 1, okay, and then find the derivative of that and set it equal to 0. That's it, okay? So I say that's it, but there's a lot involved in that, right? So, okay, can I move this off? Are y'all done with this page? Okay, I'm going to give this to Courtney. Courtney, this only doesn't include like one line. Okay. So you can take like a quick picture of it and then just keep a page blank if you want.
Thank you.
Okay, let's do another one. We're not going to do any two that are exactly the same, okay? All right, so if an open box is made from cutting a 10 sheet that is 16 inches by 10 inches. Unfortunately, these require a lot of explanation, the word problems themselves, and cutting out identical squares from each corner. And bending up the sides. To form an open box with no lid. So I want you to determine the dimensions of the largest volume box that can be made. So I'm going to underline this so we can figure out what we're trying to maximize. So I'll give you a minute to catch up with that. I know that's a lot of writing. All right, so off to the right, let's go ahead and write what we're trying to maximize. We're trying to maximize volume. Okay, so maybe a picture will be helpful. So let's go ahead and draw the 10 sheet that we were given. So the 10 sheet is 16 inches by 10 inches. So what they're asking us to do is cut identical squares out of each of the four corners. And then you're going to like throw away those pieces and fold up the flaps. Does that make sense? So like this will fold and be an edge, this will fold and be an edge, so it'll be like a 3D shape, okay? The problem is, do we know how much we're going to cut off? We don't, right? Luckily they are squares and they're all identical to each other. So if we don't know the measurements of one side, what are we going to call it? X, right? But it's a square, so both measurements are X. And then notice they're all X's, right? All right, so what is the formula for volume of a box? Notice the volume isn't affected by the fact that it doesn't have a lid, right? Volume is like how much it's filled up, right? So it could be like liquid or something. So what's the volume of a box? Yeah, length times width times height. Okay, so why can't I just run forward with that formula? Three variables, not one, right? And I definitely want to only be using one, okay? So let's go back to my picture and see if maybe I can rewrite some of these variables in some different ways. I think I'm going to be able to rewrite length, width, and height. Okay, so let's think about that for a minute. If we say the length is 16, okay, the original length of the 10 is 16, right? But we're not going to be using the full 16 inches, right? What are we going to be cutting off of it? An X here and an X here, right? For a total of 2 X's, right? So we're going to take that 16 and we're going to subtract off 2 of those X's, like whatever they are, right? What about for the width? Same kind of process, right? We're going to start with 10, but then we're going to cut this piece and this piece off, right? So it's going to be 2X. What about height? Like picture the box being folded up. So how tall is the box now? The box is X tall. And so what's the benefit of me doing what I just did here? Now I have only one variable, right? So now I can come back up here and rewrite volume as 16 minus 2x times 10 minus 2x times x. Okay. Now, I don't want to do product rule probably, right? So I want to find the derivative of this, but what do I probably need to do first so that it'll be easier to find the derivative? Like work all that out, right? Like distributive property it out, FOIL it, all that good stuff, okay? So I'm going to be confident that you could do that on your own, but you will get 4x cubed minus 52x squared plus 160x. It should make sense to you that we get a cubed because it's 3 dimensions, right? So it's like length times width times height. So I don't set that equal to 0, okay? What do I do first? Find the derivative and set the derivative equal to 0. So it's 12x squared minus 104x plus 160. And I'm going to set that equal to 0. But these numbers are quite large, so try to simplify them whenever possible. So what's the largest number you could pull out of everything? Can't do 12, unfortunately. You can do 4, though. Okay, so this is going to be 4 times 3x squared minus 26x plus 40. So what method do we use if you're struggling with the factoring part? Well, yeah, factoring doesn't work, but this one does factor. AC method, yeah. I don't want to go back and do all of that, but you know that this is going to have to be 3x and this is going to have to be x, right? Because these have to multiply to give me 3x squared, and then you can just kind of insert and fill in. But this does work out to be minus 20 minus 2. Okay, so now what? What would I do with each of those? Set them equal to 0. So I'm going to get 20 over 3 here. Okay, I'm going to rewrite that because it's probably going to be helpful. That's 6 1/3. 6 2/3, I mean. And I also get x equals 2. Okay, so one of these is invalid, but maybe not for the reason you think. We can have fractions. That's not what makes this one invalid. This one is invalid, though. So look back at your picture. What do you see as the problem of cutting off each square measuring 6 2/3 inches? Yeah, you're going to have more cutting off than you actually have, right? We actually couldn't even cut even up to 5, right? If you cut 5 here, you're going to cut the whole thing off, right? You're not going to have anything left to make your box with, okay? So I'm going to say this is invalid. But I want you to say it's not because it's a fraction, it's actually because it's too big. Okay, so by the way, what's the understood kind of range here, or the understood domain? We need to stay between 0, although that would be goofy, right? That would mean we're not cutting off anything. So maybe not including 0, and we can't go higher than 5, right? Probably not even up to 5, okay? So this is the answer we want to keep. But notice the problem asks me for dimensions. Okay, so that's not hard, right? I can go back and plug in 2, okay? So let's go back and plug in 2. So what do we get for length? 16 minus 2 times 2 would be 12 inches. Plug 2 in here and we're going to get 6 inches, right? Here we're going to get 2 inches. So the dimensions are 12 by 6 by 2. Now what if I would have asked you for the volume? Then you just would have multiplied all those together, right? Okay. So the hardest part can be just like visualizing the circumstance and finding the formula, right? Once we find the formula, it's pretty easy to find the derivative and set it equal to 0. That's not the difficult part. So as you're working through some of these problems on your own at home, that's what you need to really focus on. Like, can I draw a picture that helps me? Can I think about this outside of the box in some way? No pun intended, since that one was about a box. All right, so let's do a couple from your book. I'm not going to write them all out, so I'm just going to refer to the page number, and then I might verbally kind of talk about what the problem's about. So if you have a book, go ahead and get it out, because it's probably easier to read it yourself. But I'm going to read it out loud too. All right, so we have a charter flight, and if exactly 200 people sign up for the charter flight, then each person is going to be charged $300. But if more than 200 people sign up for the flight, and it says assume this is the case, then each fare is reduced by $1 for each additional person. Determine how many passengers will result in a maximum revenue for for the travel agency. Okay, so first let's talk about what we're trying to maximize. We're trying to maximize revenue. So you don't need to be a business major to think about this. Okay, if you're the travel agency, what 2 pieces of information would you need to know how much you're going to make on this flight? How many people? And price per ticket. That's the 2 things, right? How many people times price per ticket, okay? So, in general, this is what we're going to need, right? People times price per ticket. Okay? But we can't use X for people and Y for price, because then what would we have? How many variables? 2. So we want to somehow get it to where we only have 1 variable. So this is a trick that we use kind of a lot. We're going to let X be not the number of people, but the number of people above 200. Because notice in the problem it said we're assuming that we're going to take more than 200. So if we let X be the number of people above 200, now let's see if we can come up with a revenue formula. Okay, so I'm going to have 2 expressions, one that represents people, and one that represents what? The price per ticket. And I'm going to see if I can use X for both, because if I can, then I've done the hard part, right? Okay. So how many people am I starting off with? I'm starting off with 200 plus some unknown extra number of people, right? So it might be 50, it might be 20, it might be 5. Okay. So if we read the problem again, anytime we have more than 200 people, the flight fare reduces by $1 for each additional person. Okay, so what did the fare start off with as? 300, but what's happening to the price of the ticket every time we add more people? We're minusing by however many people there are, right? Because it's 1 for every person. In other words, if there were 20 extra people, everybody gets to pay $20 less per ticket. Okay, so now notice, what can we do? Now we can just, FOIL it. Okay, so the revenue is going to be negative x squared plus 100x plus 60,000. But I don't want the revenue. What do I want? I want the derivative of the revenue. Okay, so if I take the derivative of the revenue, what will I have? Negative 2x plus 100 equals 0. So notice this one's actually easier than the first 2, I think, once you get the formula. Okay, so what do you end up getting for x? 50? Okay, so does that mean there's 50 people traveling? No, because 50 represented what? How many people above 200, right? So let's use that to figure out how many people there are versus how many, what are we charging per ticket? So what would people be? 200 plus an extra 50, so it would be 250. Okay. What about price per ticket?
So 300 minus 50?
Yeah. So it's going to be 300 minus 50, which is also 250. Okay. The problem asks you for what the maximum revenue actually is, so we need to go ahead and do what with these then? Multiply them. So the maximum revenue is going to be whatever $250 times 250 people is, and that is 62,500. Okay, so again, if you can just get to the point where you have your formula, it's easy peasy, right? Take the derivative, set it equal to 0. Okay, so let's see if we can use a similar strategy with this next one. This one's from your book also. So number 20 on the next page in your book. All right, so I'm going to read it out loud and then we'll try to make sense of what we've got. Philip, the proprietor of a vineyard, estimates that the first 10,000 bottles of wine produced this season will fetch $5 per bottle. But if more than 10,000 bottles are produced, then the profit per bottle will drop by 0.0002 cents for each additional bottle sold. Assuming at least 10,000 bottles of wine are produced and sold, what is the maximum profit? Okay, so kind of like the last one, let's talk about profit. Do what? Oh, you're welcome to look. Where were you sitting? Oh, yeah, I see it on the floor. All right, so notice, what would we need for profit? We would need to know the number of bottles he sold, right? And then the profit per bottle, right? So I'm just going to write that down. So we need the number of bottles and then times the profit per bottle. Okay, so how many bottles are we selling at least? 10,000, right? So just like the last one, we're going to let X equal what? Not 10,000 because that's not a variable, right? But we're probably going to let it equal what? Yeah, the number of bottles above 10,000, right? Okay, so let's talk about what profit would be then. So how many bottles? We're going to do bottles times profit per bottle. Okay, so similar to the last one, what are we going to do for bottles? It's going to be 10,000 plus X. Okay. Now, the profit per bottle, if you're not looking at your book, started off at $5, okay? But then what's happening to it? There's a reduction in 0.0002 per bottle, so how am I going to say that? 0.002x, right? So I'm subtracting that off. So now notice it becomes just like the last one, right? So all we need to do is what? Foil and then take the derivative, okay? So I'll let y'all foil that for a bit. So see if you can fill that in and then find the derivative and set that equal to 0. I'll give you like 2 minutes. Courtney, did you have any homework to turn in?
Yes.
Oh, it's okay. No, yeah, I'll remember to switch them over. Let's go ahead and staple it to this one, because I'm probably going to grade this one in your class and give it back to you, so that way that can come with me or whatever. We need to staple it. The graphs are still without. You want to be nice and stable?
Normally I am stapler for Haley.
That's why she didn't have her staples?
Yes.
You have another one. I don't know where it went.
Yeah, that's one.
That's your goal, that's your job?
Yep.
Jaylee Stapler, you just follow her around?
I'm the mama. Whatever Haley doesn't have, I take care of. I remind her of everything.
That's very sweet.
It comes natural.
Well, yeah, you have 6, right?
Yeah.
And they're all at spring break.
Oh my, that is tough. All right, so what'd y'all get for the profit when you did distributed property?
I got
So what'd you get for the x squared term?
0.003.
3 zeros, right? 2 and then x squared. Plus 3x, yes.
Plus 50,000.
Plus 50,000, yes. So when you take the derivative of that, that's going to be negative 0.0004x, right? Plus 3 equals 0. Okay, so if you work that out, you should get X equals, I think I got 17,500. Wait, I got 7,500, sorry. Why did I write 17,500 though?
Because you
Plugged it back in, right? So just remember this is above the 10,000, okay? So if X is 7,500, then the number of bottles sold is actually 7,500 plus 10,000 for a total of 17,500. Okay, so I think this problem, let me read it, asks for what is the maximum profit? Okay, so I'm going to circle this. So we have 17,500 bottles, right? But in reality, we don't really have to necessarily know that, right? So what do we need to do to find profit? Plug it in, right? So the profit is going to be whatever you get when you plug in 7,500. So I'm just going to do it this way because my calculator can do it. And that way you can see what it looks like. And then 5 minus 0.0002 times 7,500. So all I did was plug that into my profit equation, right? And what you should come up with is $61,250. And we can know that's the maximum because that's a turning point, right? By the way, if we just would have sold 10,000 bottles at $5 a bottle, that would have only been a profit of 50,000, right? So you can test the end point if you want to, okay? But notice this is a lot higher than that, right? So if we're the business owner, we'd want to earn 61,250 as opposed to 50,000. All right, so I'm going to make sure that I entered it in right. Have y'all checked this on the calculator? Okay, so I want to make sure. Because I did it really, really late, and so, yeah, it is 61,250. You just never know what kind of answers I'm going to come up with late at night. Okay. So last one that we're going to do together is going to be number 10 on page 734. So I don't know if you've ever tried to mail something at the post office, but there is like a dimension that you're supposed to have when you send something that's not supposed to be bigger than that, okay? Or you get charged like a surplus charge for it being large, and it's not always, it has to like fit through a certain hole, basically. They have like a little metal thing that has to be able to squeeze through it, so it can't be too long, it can't be too wide, it can't be too tall, okay? And so if you look at the problem, it does already give you a picture of a cube, not a cube. It's actually a rectangular prism because it's not all the same measurement. So if you can draw.
Are we doing 10? Oh, is it?
10.
Problem 10.
It's problem 10, but it uses the picture from number 9. It says refer to number 9, I think. Yeah, at the end. All right, so this is the dimensions that it gives us, x by y. Okay, so we're supposed to be, that's why I said it's a rectangular prism, right? It's not actually a cube if it's not all the same measurements, okay? So we are trying to maximize volume. So what would be the volume of this rectangular prism? It'd be x by y, right? So how could I write that kind of more condensed? X squared y, right? And that is supposed to be 20. Actually, we're not trying to maximize volume in this one, so just get rid of the word maximize. I think we're trying to minimize costs is actually what we're trying to do. All right, so we have a volume formula, okay? So let's keep reading on this problem. There's different costs of material for each of the different sides. Okay, so let's look at our cube. Or not our cube, our rectangular prism, sorry. How many sides does this rectangular prism have?
12.
I'm not talking about, you're maybe giving me edges. I'm just talking about flat sides.
Oh.
6 sides, right? So I think you're giving me edges, yeah. So we have a top and a bottom and 4 like vertical sides, right? Does that make sense? Okay, and notice the pricing is different for all of them, okay? So let's, actually what we're trying to minimize, we're gonna come back to this, so maybe skip a line. We wanna minimize the cost. Okay, so this is what we're gonna need. We're gonna need different expressions for the cost of the base, the 4 sides, and the top. Okay, because if you read through the problem, the shipping materials are different for each of the different types of sides. Okay, so if you read the problem, how much is the base going to cost? It's the second sentence. If the material for the base costs what? 30 cents. Okay, so we're just going to say, okay, it's 30 cents. And then how would I talk about the measurement of the base? Just that bottom. Well, if I was going like area, though. This is like surface area, basically. It'd be x squared, right? Okay, so let's skip the 4 sides. We'll do that in just a bit. Let's do the top, okay? So if you read on through, it says the material for the top costs 20 cents per square foot. So how would I write the top? It'd be 20 x squared. The sides are going to be a little more of a challenge. How come? Because there's x and y both, right? There's also 4 of them, right? So we're going to be charged 10 cents, okay, for every one of the 4 sides that are each x, y. Okay, so let me stop right there. Does everybody get where I got that from? The 10 is from the 10 cents in the problem, and then y is the 4 there. Because how many are there? 4 sides, and each of them is x by y, right? Okay, so here's my cost formula, right? What's my problem? There's 2 variables, okay? So which variable would I like to not be there then? I would like the y to not be there, okay? So what can I do with my volume formula up here so that I could get rid of the y? Like, couldn't I solve that equation for y up top? Okay, so what would y be equal to if I use that? It'd be 20 over x squared, okay? So now I have a cost of, I'm going to combine like terms, 50x squared, right? Because 20 plus 30 is 50. And then I've got plus 40x, but then instead of y, I'm going to insert what y is, which is 20 over x squared. Okay, so later on, if you're looking back at this, we put that in for y because that's what we found y equal to. But can't we simplify this a little bit? So in other words, we don't even have to have a fraction when all is said and done. Well, yeah, actually we do, never mind. Just kidding, okay, but it'll be a nicer fraction at least, okay? What's going to happen to one of the x's? It's going to go away, right? So we're going to get plus, what? What's 40 times 20? 800, right? And then it would be over x, but how could I write that nicer since I know I'm going to need to take the derivative? X to the negative 1 power. Okay, because I don't really want the cost equation. I actually want its what? Its derivative. So I'm going to get 100x minus 800x to the negative 2, and I want to set that equal to 0. So here's where your algebra skills come in. Okay, so we've got 100x minus 800 over x squared equals 0. So one way to do this is to eliminate fractions. We don't usually love fractions, right? So what could I multiply the whole equation left and right by, and it would get rid of fractions for me? If I multiply by x squared, that's going to do it for me, right? But I have to make sure I do it to everything, right? So what's going to happen in the first term? I'm going to get 100x cubed, right? But the point of it was what's going to happen to the second term? They're going to cancel, and we're just left with what? 800. Nicely enough, on the right side, what happens when you multiply 0 by anything? Who cares what it is? Still 0. Okay? So now I think we can solve this. Okay, so we could move the 800 over. So we've got 100 x cubed equals 800. Then what do you notice we can do?
And
Divide by 100. So I'm going to write in what I did here for the people that aren't here. So I end up getting x cubed equals 8. So now what?
Cube both sides.
Well, I think you know what to do, but you're just saying the wrong thing. You don't cube both sides, or it's already
Oh,
cubed.
you square it.
Cube root it, right?
Yeah.
Yeah. I think you already knew what the answer was, but yeah. So if we cube root both sides, you're going to get x equals 2.
It's been a while.
I get it.
Words don't work right now.
I understand. Okay, so if x is 2, let's go back up to the picture, okay? So if x is 2, by the way, this is 2 feet. Okay, that means 2 of the dimensions are 2, right? But how could I figure out y then?
Well, you plug it in.
Plug it in, right? So y is going to be 20 over 2 squared like we had over here, right? So it's going to be 5 feet. So the dimensions are what?
2 foot by 2 foot by 5 foot.
Right, 2 foot by 2 foot by 5 foot. By the way, the order of the sides really wouldn't matter to me. Okay, so in other words, the box can't be larger than that. Okay, or you get charged an extra fee. Okay, so I hope you can see, although these 5 problems we did in class were very different from each other, is pretty much the method that we're using very close. It is, right? Okay. All right, so we have just a few more minutes, and what I want us to do is I want you to try a couple of them on your own, okay? If it makes you feel better, I'm actually not going to give you homework for this section, okay? So this is considered in place of homework, okay? So keep that in mind. So I do want to look at it before you leave, but I want you to do number 4 from the section. So this is to work on in class. And then instead of homework, I want you to do the review, basically. So I want you to look at number 4 and number 19. Number 4 is different than the one that we did. Okay, so if you look at the picture, they added something a little different. So I want you to see if you can do number 4, and then you're going to show me this kind of before you leave, and then also number 19. So if you're at home, then I want you to do number 4 and 19 and send those to me. So I'm going to go ahead and stop the recording. Maybe. If I can find my mouse there.